Okay, just so everyone knows, we're starting the recording. So welcome to our second Dapr community call. It's fantastic to have everyone here. We have a packed agenda for today, but as always, we want to leave plenty of time for you to ask questions at the end. So, feel free to kind of think about what questions you're going to add. We thought we'd start this off with a little demo first from Haishi Bai. But before we do that, let's just do a short round of introductions first, just because I think it's always useful to make sure that we just level set of who's on the team, because it's useful just to make sure that you know who the Dapr core team are. So we'll just do a little short round of introductions of the people who are on the Dapr core team, and then we'll dive into it. Haishi, who's one of those members, to do a demo for us. So I'm Mark Fussell, and I'm the product manager for Dapr.
Hey, I'm Luke Kim. I'm the engineering manager for Dapr and the lead for incubations in the Azure CTO team at Microsoft.
I am Yaron. I'm a software engineer on Dapr, part of the incubations team. GitHub handle, Yaron too.
Hey, my name is Yongbu. I'm a software engineer working on the Dapr project.
Hi.
Go ahead.
Yeah. Hi. I'm Shalab. I'm an engineer in Dapr core team.
I'm Haishi, also known as Iron Man, developer on the Dapr team.
Okay, I think that's everyone. There's a couple of other people who are on here today. I think a man is not on here just yet. If he is, he can introduce himself a bit later. And then we also have Leon as well. Fantastic. Right. So let's dive into a demo. Haishi, given you got such a splendid background,
Right.
You're going to show us a little demo of distributed tracing.
Right, exactly. So let me share my desktop. How much time do I have?
Oh, you have a good, 10 minutes.
All right.
Take your time.
Can you see my desktop?
Yes, it's a calculator. Is that correct?
Right. So that's what I'm going to use. That's one of the Dapr samples in the sample repository. This is a distributed calculator where each operation is implemented as a microservice in different languages. I think we used Go, Python, and some other languages. So the idea is to use distributed tracing to trace the call tracks to see what's happening, what kind of interactions happening between the components. So to enable this, basically this is the application with 5 microservices. To enable the tracing, what I needed to do a couple of things. First, for each of the components, for instance, this is the front end, calculator front end. I need to add an annotation to my container to specify a configuration file or configuration object. And then I need to define this configuration, which I have here. Currently, we have a tracing spec in the configuration where you can turn on or off tracing. And you can specify if you want to record all the HTTP request parameters, as well as the HTTP body in your tracing files. Then our tracing is using OpenTelemetry, which supports a concept called exporter. Basically, the exporter is pluggable to OpenTelemetry that can export your trace files to all kinds of different destinations. At this point, we support 2 types. And of course, we'd like to see more community contributions to support more exporter types. The 2 types we support, one is the native type. This is a native OpenTelemetry exporter. It's very simple. Basically, it just streams the tracing spans into a destination address. And the other one we support out of the box is the Zipkin. So in this case, you can just specify a Zipkin endpoint where you want to dump your trace files. And that's all the configuration I need to set up. By the way, you can enable as many exporters as you like. You can have multiple exporters. The trace files will be exported to all the configured exporters. And if you look at the file, the source code, this multiplication service written in Python. And that's all the service code is. You can see there's no Dapr library or any tracing library included in this. And also you don't need any annotations or instruments in your code. So the goal of Dapr distributed tracing is to enable you to configure and use distributed tracing without even touching your code. So this is becoming complete operation concern in certain way, which meaning you can design your tracing strategy and configure your exporters independent from the source code. And what we did is actually we have Dapr middleware plugged into the HTTP or gRPC pipeline. And we are intercepting the calls, and we are generating correlation IDs and pass that correlation ID along the call chain so that we can collect the complete call chain from across multiple components. So let me show you. I already have this application deployed. You can see I have the adder, the front end, the divider, multiplier, and subtractor. And my calculated front end is running on this external IP. On this window, I also set up the port forwarder to forward the Zipkin port to my local host because I have a Zipkin container running on the same cluster as well. So in this cluster, what's the name? I forgot. I already have the exporter defined. You can see I have the native exporter and the Zipkin exporter defined as Dapr components. And you can see I have the configuration with tracing enabled deployed as well. So now I can just go to my application and start to generate some load, like 9 times 6 plus 3 minus 5 divided by 9, something like that. And if you go to Zipkin, this is connected through the Zipkin exporter. You can see I have some traces. This is less than a minute ago. This is one of the divide operation. You can see the client request coming into the Dapr sidecar and leaving the Dapr sidecar, entering another Dapr sidecar and going into the application code. And if you drill into this, because I turned on the headers and bodies, you can see all the HTTP headers as well as the body is tracked here. And if you want to understand the topology of your services, you can just go to the dependencies view. You can see this kind of nice view about how your services are calling each other. And all this is done without annotating your code in any way. The other exporter, the native exporter, we configured it to export to Azure App Insight local forwarder. A local forwarder is this agent that you can deploy on your machine or on your Kubernetes cluster. that can take the trace spans sent to the folder and send it to app inside. So this is how we configure this, and we are dumping all the tracings into app inside through the local forwarder. And if I refresh my data, you should see a similar view onto this. You can see the, let me zoom in a little bit. You can see my front end is making this number of calls and my average response time to the calls. And you can see my front end is also calling the Dapr state endpoint to preserve state. And there, when there's some components update, actually there's a local calls. Actually, these are supposed to be into individual application code, but because at this point we don't distinguish the user code at this point, so that's why you see only one node. But in the future version, what you're supposed to see is these services calling into the corresponding user code. So this is some improvements we're considering. This is it. That's how you configure and use distributed tracing. As I mentioned, we have this middleware mechanism to enable this distributed tracing. And we are considering to extend the same middleware mechanism to support other scenarios, which we can discuss next. So that's my demo. Mark?
Me on mute. That was fantastic. Thanks, Aishi. Maybe there's a chance if anyone has any questions that they want to ask you about anything, maybe we'll open it up, and if there's anything that's interesting that people want to ask, or they had questions part of your demo, feel free to, just type something in the chat window, just open up your mic and just talk. It's easier, much easier to talk and just ask the questions that way. So,
hey guys, this is Lynn.
Hi, Lynn.
Quick question for you. So this is great. I mean, that was a great demo, Aishi. Really cool. My question really is, so that's great for everything that's basically Dapperized, but what does tracing look like if I'm calling out to an external service someplace? Do I get any tracing information there as well?
That's a very good question. So as you mentioned, for now, the distributed tracing is just to help you to establish the topologies of the services. In terms of user code tracing, we are not sure what's the best way to do this. One possible design is for the Dapr to expose a new endpoint, like the tracing endpoint, that the user can just talk into. But I'm not sure, because each tracing will occur round trip to the Dapr sidecar. The other way is to provide some kind of libraries or instructions for user to actually instrument the code, and we can collect the tracing using open telemetry as well. So at this point, I'm actually uncertain what's the best way to approach this, and we're open to suggestions.
One additional point there is that if you're talking to an external service through a Dapr binding or component, for example, a state store, which you saw in the demo there, it will actually be captured and showed up. So Aishi showed that little circle on the application map there, which was the state store. So if you plug in a backing component such as Redis or Cosmos DB or DynamoDB or whatever, we will capture that tracing. It's only if you make a direct call, not through a Dapr binding, to an external service, that is the thing that we currently don't capture.
Okay, makes sense.
There's a couple of other questions in the chat window from Yuri. He says, wondering why do we not just direct everything to App Insight?
Yeah, we don't want to tie into a specific platform. So open telemetry, as we see it, it's kind of has a wider adoption and has a lot of exporters that allow us to build support into many more systems. So that's why we chose the open telemetries.
And he also does the telemetry format support Custo.
I'm not sure.
I think it's when it goes actually into the store, yes? So in the App Insight store, once it's there, you do Custo queries over them.
Yep. So the backing storage for App Insights is actually Custo. So
yes.
The way you get into Custo is through the App Insights connection.
Yeah.
And just on the point before that, the project is all about being open. So like we say, any programming language, any framework, any platform. And so that principle extends to everything we do, including kind of the different telemetry formats, right? And so what we want to do is make it available that you can use. We don't kind of tell you that you have to use, a telemetry system, but you can kind of plug in the one that you want to use that works best for you in that kind of open principle manner. So.
Good. Well, on that note, it was a fantastic demo. Thanks, Heishi. We'll spend some more time making sure that everything Heishi's shown today gets into the docs. There's some docs there already on how you set up the telemetry, but I think there needs a few more that you intend to add. Isn't that correct, Heishi? I think there's a few more things to come, yes?
Yeah, we have a PR pending to be merged.
Yes. Okay. So that's something that we're hoping to get done in the next week or so. So then on that note, let me just switch back and share my screen here a moment. Couple of other things I just wanted to point out to, so on our community call, this is all information around it all. One thing that happened last week is that we had a conference at Ignite for Orlando, and if people have a chance to listen to Mark Razonovich's talk that we've put as part of the community section here inside the Dapr repo, I'd highly recommend that you go and listen to Mark's talk where he covers the open application model, OAM, and also Dapr, and how they both kind of independently, one describes an application model and Dapr as a praying model. So go and check that out, listen to it all. I think you'll find that it really provides a very crisp, clear definition of what the project's goals are, and also some fantastic demos around it all. As we just carry on down our agenda, one thing that we wanted to highlight that in the last couple of weeks, we've seen a significant number of community contributions, which we're pretty excited about. And we've shouted out a few of these on our Twitter handle, Dapr Dev, to kind of acknowledge some of these, and as they get all checked in. But we've had Memcached, Google Cloud Firestore, and the Zookeeper State Store added as state stores into the components contrib. If you go and look at inside our components contrib library here, you'll find them under here. Here's the state stores inside here. So here's Firestore, here's Memcached, and here's the Zookeeper one that got added. We've also had 2 pub subsystems for NATS and Azure Service Bus. And again, if you go and look at the components contrib inside here, if you go and look at the pub sub side of things, you'll find those checked in now. So go and check those out here. And then finally, adding HashiCorp Vault for Secret Store and authentication over Kafka bindings were great additions that we found. We're also just adding into the secrets management and also authentication across Kafka. And finally, actually, I don't know about this one, actually, Docker network support for CLI. So we should probably talk about what that one is. So, Yaron, what was that one that got added?
Yeah, so Philip added support for when you run Dapr locally using Docker, because a replacement service runs Docker and Redis runs Docker. So
Yes.
he put in the option of adding them to a specific Docker network.
Oh, okay.
Which
That's
is,
cool.
which is great for isolation and being able to basically running multiple instances of them and a few other things. So thanks for that.
Cool stuff.
Yep.
So that was under, and so there's new docs in that underneath the Azure CLI that describes how to use it.
Yes, correct.
Okay, great. So so we want to shout out, so fantastic, helping grow the project around some of these things, and it's a great indication that we think that there's some great scenarios that are coming along here, and we're looking for scenarios particularly. So if you want to come along and talk about a scenario where you're using and want to use Dapr, that's particularly in a sort of a workload or a project, that's what we're particularly keen and interested in, to understand what are some of the state stores, what are pub subsystems you're looking towards, how you're trying to put those together in solutions. For us, it's really all about the customer scenarios, how we're going to build those out and make sure that we get everyone having workloads that we can work towards getting running in production. So as I mentioned on the last call, our strong desire is to get the stable set of building blocks that we put out, the 6 types of building blocks that we had, stable and tested, particularly in long-running production workloads. So as we look towards next year, we can start talking about a GA timeframe around some of those things. On that note, this week we've been working on the 0.20 runtime release for Dapr, and you'll see that that's part of our milestone inside here. This is our milestone inside the Dapr repo here. You see that we have a number of open issues inside here that we're still looking to get closed. A lot of the focus of this release particularly was to try and get an end-to-end test test framework in place, so we can actually do tests that cover across a number of the different building blocks and the components. And so we are able to make sure that we have good test coverage for when we add new capabilities or bring in new components, to make sure that those run as part of the development and check-in process. So you'll see that's sort of a major feature. You actually see inside the closed side of issues inside here. A lot of it really was to do with integrating many of some of the components into the component contrib, like Zookeeper, MongoDB, and the NAT server. Plus there's a few other bugs and cleanup exercises that we did inside here. So go and check what we did inside some of those. And we're on track for releasing the 0.2 release of the Dapr runtime, along with the Dapr CLI release that we'll check and do for this Thursday/Friday. So watch out for that. We'll post to Twitter, onto Twitter when we get it out as a release. But of course, the repo is the best place to watch. So that's kind of our goals for effectively this week. And we're pretty excited about that because it's sort of our first release after our announcement. And so we want to get you able to kind of try it out, give us feedback, and see if it's kind of addressed some of the issues that you've raised. So at this point, I'm just going to pause, and if there are any questions at this point that people have that we want to ask about the release, and any questions about what's been happening in terms of some of the check-ins that you might have seen. So feel free to throw things in the chat window, or just open up your mic and start talking, which is much easier.
Okay, I'll try this here again. I'm wondering if there are any Helm or OCI templates which build for me in Dapr environment for testing or experimenting.
Let me just mute. Can you just say that again? Because we got someone else talking over on top of you. If you've got your mic, because everyone. Let me just pause and let me just close the mic.
Okay, my question was answered in the chat. Thank you.
Okay, you got your questions answered?
Yes.
Okay. Perfect. All right.
Yeah, so just for people on audio, that we do have a Helm chart. Jeroen linked to it in the chat window, but you can also just find it under the charts path in the main repo of Dapr. One additional note that I wanted to mention here as well is that one piece of feedback we got is the community wanted to help build this with us and kind of determine the direction of it, and that's the way we see it. So we would love to engage and have you really work with us to determine what we should build next and what we should really go after. And ideally, as Mark mentioned, that would be with a focus on actual workloads. So we would love to see some real workloads out there. To Rasmus's question, I think it's in alpha, so we wouldn't recommend you run it in production, but that's more of kind of a disclaimer. I would say if you want to go and run it out in a test deployment, would love that, right? And that will help us give us some feedback and figure out what gaps we need to fill and where we need to go next. And really, the goal for this upcoming period is to respond to the community and customer feedback and really make sure this is enabling what we set out to do, which is to make writing distributed microservices super easy for everyone, right?
Yeah, Luke, and I just want to add something to that. So Rasmus also asked if there will be a lot of breaking changes planned in the future. Yes, there will be, probably. We've actually sort of versioned our APIs in a way that we should be able to introduce breaking changes with newer version of the API as well, and trying to ensure backward compatibility. Now, we haven't tried that before because we haven't really broken any of our APIs yet. But definitely that is something that we'll try to do as less as possible, meaning breaking backward compatible APIs. But yes, you can expect some breaking changes going forward until the 1.0 release, where we will probably inspect, with the community, whether or not we need to ensure some level of non-backward compatible changes with every major version. With every non-major version that we're releasing. But until the 1.0 release, yes, you can expect breaking changes.
Okay, good. So on that note, Yaron, why don't we just switch to you, because we're going to have a kind of a discussion, or you're going to have a little discussion about circuit breaking and policies and some of the kind of ideas and thoughts around some of that. So do you want to spend some time on that now?
Yes, fun stuff. Okay, let me share my screen. Okay. So we're going to talk about circuit breaking. And before I start off, there is this issue. I didn't plan for it to be 777, but that's a pretty nice number. So there is issue number 777 on Dapr regarding circuit breaking. So it has the entire proposal overview, some architectural data, and the specs. So please, everyone who's interested in this topic, go look at that issue, express your opinions, and give your feedback, because that's going to be probably the issue that's going to drive forward the work to implement this. So what is circuit breaking? I don't know if we have enough time to really cover everything about it, but it really comes to software from electrical engineering, where you have a circuit and it can be in several transition states. So the circuit can be closed, opened, or in half state. And what it allows us to do is to be able to inspect the behavior of other services or systems that we are interacting with, and basically do something like take them out of the loop if they're too slow, if they're not responding, if they're not healthy. When we announce some certain conditions that should be met. And these external systems can be databases, they can be other services within our cluster, they can be gRPC, TCP, HTTP based. This really basically just means apply a circuit, and once you acknowledge that the system which you're trying to communicate with is slow or not responding, basically open the circuit, and during the time the circuit is open, all of the requests will not go through, and allow the system a graceful time to recover from its errors, and then in some interval allow some requests through, and if it's behaving as expected again, then you can close the circuit and traffic resumes in a normal fashion to that system. So you'll know that service meshes like Istio and Linkerd-1, because I don't think Linkerd-2 has it, and maybe even Traffic implement the circuit breaker policy. So this is sort of in line with what we're expecting Dapr to implement, but there is one major change. So let's take a look at this component spec here, which is being proposed. And this is a proposal for how I would basically define a circuit breaker. So I have a name, it's called myCB, and it has a type, policies.circuitbreaker. And this is a component spec because we want circuit breakers to be components just like any other state stores or pub subs are components. And so you can implement several, we can implement the default one, and they have a bunch of metadata that you can define and configure for that specific circuit breaker. So this proposal has some pretty basic configuration. So let's just go over the metadata and take a look. So max requests. This is basically the number of requests that Dapr will send to the destination system when the circuit breaker is in half-open state, meaning when after some failure has been reported and currently we're not receiving traffic. So a certain amount of time will pass, the circuit will go into a half-open mode, and then this number of requests will be allowed to go through to basically check if the underlying system which we're trying to communicate with is actually healthy again or not. Interval is the amount of time that passes when the circuit breaker will basically cancel out error states. So for example, if I tried to contact some other service and it failed 10 times, and then I defined an interval of 5 seconds, then all of the error counts that were aggregated in the last, let's say 10 seconds, will be cleared within this specified interval. The timeout is the time to wait before the circuit becomes half open. Meaning if everything is okay, so that's the time it takes basically, if everything is not okay and the circuit is in a closed state, meaning I drove some traffic and the circuit breaker has decided that no further traffic will be allowed to the destination, that's the amount of time which the circuit breaker will wait until it starts inspecting if the underlying implementation is healthy again. Rule.latency is one of 2 rules that are proposed. So it can either be rule.latency, rule.failures, or both. And that is basically an expression that says this is what will trip the circuit and count as an error. So for example, in this example, we're saying if you're encountering a latency greater than 500 milliseconds, and that occurs for a consecutive 5 times, then put the circuit inside closed mode, inside open mode, and just don't send any more traffic. The rule.failures is when the other endpoint which you're trying to contact responds with a failure, and then the question is asked, well, what is a failure? So for things like STO, it can mean none to 100 HTTP requests. But we can introduce more rules that explicitly allow you to basically say what you consider as a failure or not. And then the greatest departure, I think, from circuit breakers today is rule.targets. So you can basically take this circuit breaker and apply it to bindings. So for example, if you have a Lambda binding, a Dapr binding, you can say, well, I want to apply the circuit breaking rule both to that specific binding, whatever it is, and also to an order service, which might be another app running in my cluster. And finally, rule.apply_to mentions which services in my cluster, which Dapr-enabled services this rule applies to. So star will basically apply the circuit breaker rule to all of them, or it might apply to some of them. Now, why is this beneficial? Let's say, for example, that you're using PubSub. You're using the Dapr PubSub with 2 services or 3 services, A, B, and C, and you want to say that you can expect some delayed latency from services A to B, but service C is actually something with a higher SLA, and you basically want to allow its messages to pump through as much as possible. So you can apply the circuit breaker rules to services A and B, and then if they encounter the open circuit mode, for example, if the PubSub is not responding, they will actually hold back. They will not bomb the PubSub with all the requests coming in, but service C will just continue as usual. So if any messages go through, they will go through service C, while A and B are basically waiting for the circuit to close again and return to a healthy state. So again, just to summarize, this is the configuration that are currently being proposed. You can use this, you will be able to use this independently of circuit breaking with service meshes like Istio or ingress routers like Traffic. And what this gives you also, again, is the ability to apply them to individual services and have your destination targets be Dapr bindings, Dapr pub sub, your state store, or other services, or even this is a good example of an HTTP binding, which can encapsulate any non-cluster system which you want to talk to, for example, like Azure Functions or Lambda, or anything with a public external IP. So now I'll open this up to questions because I gather there are many.
Yeah, there's one from Johnny. I don't know if you want to talk.
I actually see I see 6 on the window.
Yeah, well, Johnny, I don't know if you want to talk or if you want me to read it out. He says, how would you support a combination rule where the rule.latency is greater than 500 milliseconds or the rule.failures is greater than 6?
So the initial thinking is whichever comes first basically trips the circuit. Now, what we can also do is allow for a more granular expression language, which basically has just a rule, and then you can basically do an and or a condition based on the rules that you apply. So these are 2 ways in which we can address this.
Okay. Ramos says probably nitpicking, but why prefix some rules with rule and not others?
So which rules exactly? So if we, why prefix? So, okay, because these are basically configurations for the circuit breaker itself. And these are rules for when the circuit breaker really kicks in. So this is more of flat level configuration for the breaker. And for example, we might take rule off of here and here. Like this is a rough draft, right? None of this is really finished. So, thinking about it, I would probably leave this as is. I'd probably put rules on latency and failures and threshold and just call targets and apply to something like destination or source or something like that. But yeah, but a fair point. So if you have feedback about the naming of the metadata properties, we'd love to hear that.
If anyone else wants to just kind of open up for questions and ask and just talk, that's a lot easier. Just to open up your microphone and feel free to ask questions.
Yeah, and this really is like a heavy topic. So I would expect to see more feedback once this issue has been read. And again, I encourage everyone to read it. Something else I just want to specify is that you can check out issue 767. Which enables us to insert these circuit breaking policies on pretty lower infrastructure levels of Dapr. So for example, because this will tie into our middleware, you'll get distributed tracing for circuit breaking too. So you'll be able to see traces like service A tried calling service B, but it failed consecutively with 10 retries because the response latency was larger than the rule which I defined, like 700 milliseconds. So you will be able to see all that inside your distributed traces.
Okay, very cool.
I've got a quick question. I think Haishi actually asked it, so I would love for you guys to answer it as well, because I was a little confused as well between the difference between targets and apply to.
Yeah.
Can you go over that one more time, Yaron?
Yeah, so targets is the destination services which the policy breaker will check. So if you apply the circuit breaker to bindings my function, it will apply to that specific binding or that specific service. So whenever your Dapr sidecar will try to invoke my function or order service, the circuit breaker will kick in. Apply to meaning apply to have the circuit breaking apply to a given service in my cluster. So maybe I should have put a different service name here. So if I have order service, let's imagine that I'm going to have like I don't know, shopping cart service, right? So if I have the circuit breaker in place, the circuit breaker will only kick in for these targets, but they will only apply when they're being called from the shopping cart service. So this is basically what it means. So by putting asterisks here, it means that every Dapr-enabled application in my cluster will start enabling the circuit breaker for these specific destinations. And if
so the apply to is like the source then,
yeah,
right?
it's like
so
the
where it's
source
coming
of
from.
the
Okay.
destination. Yeah. Yeah.
Gotcha.
And again,
That makes sense.
like apply to and targets, they might be better off being destination and sources. Yeah.
Or apply to target and apply to source. That might be a.
Yeah, that might.
Just
be.
thinking out loud.
Yeah, exactly.
Yeah.
And also, I'm not sure if we need to consider the case that a specific pair, like a service A calling service B, only in that case will apply this policy.
Yeah, so this is what the apply to and targets do.
Right,
So
but if you have the source list and target list, that implies all the combinations of the source and target will be applied, right? If you
okay.
have two caller AD and two destination CD, I only want to apply the policy when A is calling D and B is calling C.
Yeah, this is a good point that I actually wanted to ask to the community, which is, as you can see here, we could build out any number of functionality and pretty expansive. We like to try and use the principle of simplicity. And so what we need is the community input to say, okay, we actually need this piece of functionality versus like, we don't need all of this other stuff, right?
Yeah.
So if that's something very specific that someone needs, then that's that type of thing we'd love to hear. Because otherwise we probably shouldn't build it, right?
Yeah, we want to stay clear of over-engineering problems that, for example, if you look at Istio, you can apply a circuit breaking rule like for one given service globally within all of the systems, and everyone will get it. So this type of thing is sort of on
we could go two ways here, right? We could expand this to be more complicated, more granular, or we could actually make it simpler. And for example, you could have not even a source and destination and just say, if there's any call that comes from or to a service called A, then apply circuit breaking.
Yeah.
So.
Yeah. From my experience, it should be simple works, and it should be target agnostic. If on the client side, the decision is, here is a set of rules when I need to break the circuit, it should be client driven.
Mm-hmm.
It doesn't matter which call or for what reason, delay or circuit got break. It's just client perspective of what needs to happen and fail fast.
Yeah, I think that's good feedback.
Targets make sense. I think that the apply to, I would have to understand what some of the use cases are there. Like, if the target was A, why would I, apply that if it was coming from microservice B and not from microservice C? Like, what is the real world use case of something like that? I mean, if A has got an issue, it seems to me like it would have an issue regardless of where the originating call was coming from.
Yeah,
yes,
so the apply to, so it will be applied to A and be routed to service C. So if service C has an issue, so A will, it'll open the circuit and A will not drive any more traffic to C, but you might want B to be able to drive some of the traffic to it because it's of a higher priority.
That's why like having some actual good examples from the community about some actual workloads, I think will really help solidify.
Yeah,
I agree.
The direction.
Yeah, for sure.
Yeah, it is also the question of philosophy, microservice philosophy, because in my organization, the architecture I support, they don't allow one microservice calling another one. The aggregation, in my opinion, should happen on a client side, but it's a matter of perspective. I'm not, saying that this is the only way to implement microservices. But again, it's an area of philosophy.
Mm-hmm. Okay.
Great.
Good stuff. All right. Well, thanks for proposing that, Yaron. We'll just keep that as a proposal inside there, so people can come along and comment. And we're not too sure when this will actually go in, but we're just looking at getting feedback on this. So add feedback to this, and we'll come back and revisit this sometime in the future.
All right. Thank you.
We've got 10 minutes, so I wanted to make sure that people had time to ask questions that hadn't come up yet so far, before we kind of dive into anything else that's left. So if people want to post any questions in the window that they're burning topics, or they want to just open up their mic and ask some things, feel free to go ahead. And let's just kind of give some time to see what your questions look like.
Yeah, one question from my side. I wanted to hear from the core community on the E2E test architecture, and if you could shed some light on end-to-end test architecture.
Okay, what the end-to-end testing goals are, and how it actually.
Yes.
Young Boo, do you want to be able to spend some time on that?
Yep.
Or is it?
Let me share my screen.
And certainly what we can do is, I didn't actually put this on agenda today, and actually that was a good question to bring up, given that the focus of this now was to get some end-to-end testing in place, so that we could make sure that we had broad coverage across different components and the different building blocks. We'll certainly make sure there are docs in place and to describe all this, but maybe in our next call we'll dive into this a little bit more if we need some more time.
Okay.
Can you see my screen?
Yes.
Yes.
So right now we are planning to two iteration for E2E test. For the first iteration, we will our goal is to have the test framework for E2E test, and then this iteration will be delivered in this milestone 0.2.0. So in this iteration, we will have first the test framework for E2E test, and we will have one simple E2E test, which is using state store. And we will add a pre-submit test to PR build, and we will provide a document how to write the E2E test with Dapr. And once we done the iteration one, and we will for the second iteration we will implement the Dapr core component E2E test. For example, like these list, service invocation, and state management, secret management, etc. And for the progress of the E2E test, actually, if you go to Dapr project, there's a Dapr E2E test. You can see all the progress of the E2E test now. Any questions?
No, looks great.
Yeah, so give an example of what you're going to go work towards. Is it be able to do a test that covers using, say, for example, a state store along with service invocation? Is that some of the goals?
So actually, that goal is the second iteration. If you look at the test plan, so first iteration in this milestone, we are aiming at delivering the first E2E test framework, and then create one simple E2E test for state store. That's our goal in this milestone. And then for the second iteration, we will deliver the Dapr core component E2E test. So you can see the list of the test area.
And there'll be some docs about how people can write tests if they want to?
Yes, we will provide the documentation for how to write the E2E test in the first iteration of E2E test. So in this milestone. And
the goal is that when we do kickoff builds, each time we do a PR and pull that through, these tests will run through them.
Right. And then also, the contributor can run their E2E test in their local environment. For now, we are focusing on running the E2E test only in Minikube, but later we will have a functionality to run the E2E test in kind or Docker Kubernetes, Docker desktop Kubernetes later.
Good stuff. Thank you for sharing that, Youngbu.
Thank you.
Any plan to employ Docker Swarm at any point?
Any plans to implement Dapr on top of Docker Swarm? Well, it was raised as an issue as early on, actually, but at this point in time, you know, I think one of the key things that we had to do in this release is enable the service discovery as a component, which we didn't actually do in the first release, so that you can actually plug in the discovery mechanism for how you do calls across different components. So you'll see that there's a PR in place for that at the moment. And then I think after that, it's more of a case of coming up with a design. If you're wanting to lead a design for that on Swarm, we're happy to do it. We don't have those direct plans at the moment.
Really? Mm-hmm. Okay, fair enough.
Yeah.
Yeah, and also things that would help drive something like that would be if there is like a workload that you want to put on it, and you'll say like, I have this very specific workload, it's running Docker Swarm, and can you please help enable that? Then that helps drive forward something.
Yes.
No, I don't understand that. I don't understand that. And if we talk about the microservices and orchestration engine, right? The Kubernetes for me too centralized. While with Swarm you could build very flexible meshes, right?
Yes.
It's a generic question. It's not.
Yeah.
Too much related to Dapr.
Yeah, we have another one as well where people are saying that they want to connect with Dapr on top of Service Fabric, and that there were some people there as well. So we're actually trying to target that one as another platform as well over time.
No, I do understand. You need to be practical and reach critical mass.
Yes.
And the goal is eventually to support all of the platforms we can, right? So
yes.
I honestly speaking, I'm only kind of diving in Kubernetes only if I need it. I still keep my focus on Swarm because I see that architecturally it's much more powerful approach to orchestration. We'll see.
Okay. Yes. Okay, good. Are there, does anyone else want to throw a few questions out there that they're curious about?
I've got a quick question. So for service invocation, it looks like, and maybe I just haven't done enough testing or whatever yet, but it looks like that really from a retry perspective, you only get the retries when you're doing, a call from one Dapr component to another. Again, back to the, hey, I've got an external service call that needs to occur. Have there been any thoughts around, and if it's there, just let me know, around retries from a service invocation perspective that are outside a non-Dapperized component, basically?
So that's on the binding side of it. Are you thinking about it on the binding side of things?
Yeah. Well, from a bindings perspective, and again, I'd like some clarification here too. From what I can tell, like on an output binding, it's a kind of one and done type thing, right? You're not getting a response back. So let's say, let me give you an example. Let's say I was making a call out to a weather API or anything behind maybe API management, right? That may be rate limited, right? So I make the call. I'm going to get back a retry after, and I don't want to handle that myself in my code. I would love to be able to basically use the same semantics that service invocation uses, where I can basically, call the Dapr sidecar. Here's the HTTP call that I want to make. Here's the headers, here's the body, everything, and then have it handle those retry semantics, eventually returning me the response at some point in time.
Super cool. Yeah. I mean, you're basically asking for a general purpose kind of pass through Dapr API. They can just say, hey, Dapr, call this on my behalf. That's
exactly right. And handle all of the retry logic for me, because I don't want to have to then bring in Poly or anything else, any other library. I just want Dapr to handle it for me. I mean, that makes my life really, really easy. I can make just
and Rasmus is right. It also makes tracing easier on it as well, right?
100%. Yeah.
I think
once we have issue 767 implemented, we should be able to inject such kind of retry policies into the pipeline, so that you can just enable in your call pipeline to say, I want this call to have the retry policy applied to it.
That would be very cool and very, very helpful.
Right.
100%.
Yeah. Cool.
Yeah.
That's a good feature, like a general purpose reverse proxy for
Exactly.
some systems. Yeah, that's great.
Yeah.
Yeah, I think that was certainly the direction that we were trying to head down.
Awesome. I thought that it was, and then I was just like tried to implement it. I was like, wait, I can't do this just yet. So I just wanted to make sure that that was still on the, if it's not on the roadmap, let's get it on the roadmap, because I think a lot of people would find that very, very useful.
Yeah, and really the question there is, how do you tell Dapr what your API address is, the address of the service you want to invoke? So is it static with a file? Is it on a per basis call? Yeah, so once we nail that, I think it'll be pretty straightforward to implement. So if you could, give us your thoughts about how you'd like to see this from a developer standpoint, that'd be great.
Okay, for sure.
Okay, let's finish up with then one last question here from Ada. Is there a consideration for an event sourcing model? Ordered events are becoming a requirement for a lot of these environments, and PubSub doesn't generally offer any guarantees. So I guess your question is a question around ordered events. Yeah. It'd be good to understand your scenario around all this, because you have ordered events where you want to be able to say, lock the door, unlock the door. And the events, you don't want to have it in the wrong order in terms of how they get delivered to the end source. So anything you want to
I'll just add something. First of all, feel free to engage us on Gitter with your specific scenario, but for ordered events, Dapr PubSub, in the terms of a consumer group, it will guarantee order delivery for PubSub for consumers within a consumer group. And a consumer group in Dapr, if you go ahead to our docs repo and you read the concept for PubSub, is defined by the Dapr ID for a service. So you will get ordered events there, and then you can just use Dapr rate limiting to rate limit the amounts of events coming in concurrently into your app and just write them to a store. Then you can somehow combine a bunch of these building blocks to come up with event sourcing. There may be other ways to do that, even with actors. If each actor represents a small piece of key data, but that's not as natural, really, as
not as natural.
with a saga pattern like where you publish events in an ordered manner and then concurrently write them off in that given order to a state store transactionally. But we'll be happy to engage more on that.
Yeah. Okay, I think we are done now for this week. As always, feel free to reach out to us on Gitter and ask questions here. We're pretty active on this all the time, so feel free anytime to post questions there, and we'll get you answers. Also, feel free to kind of join us on the next call. The next call will be 2 weeks today. It'll be on the 26th of November. Same time, 10 a.m. on Pacific Standard Time. And yeah, we just look forward to raise issues inside the repo, put comments inside some of the proposals, and later this week when we come out with a 2.0 release for the Dapr runtime, we'll give a big announcement, and we'll have a bunch of release notes with it all, and hopefully you often enjoy that. So thank you everyone for joining us this time, and we look forward to talking to you on all those channels. Thanks.
Thank you.
Thank you.
Thanks. Bye.
Thank you. Bye-bye.
Thanks, guys. See you.